Alright, y'all, here come the notes after the test. Section 5.1, this is chapter 5, is all about exponents. A good review for many of you who might have forgotten some of the exponent rules. I'm starting on the first page, on page 360 if you want to join me. And we're talking about this definition and what it means. That b to the nth power just means b times b times b times b times b n times. Right? N factors of b. I don't like the way they even say that. So let's just write our own example here. So b to the n means b times b times b times b times dot 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 b, and then below here I just want to see n number of times. Like for instance, in the book it gives you 6 to the second power. That means 6 times 6. It gives you negative 1/2 to the third power. That means negative 1/2 times negative 1/2 times negative 1/2. And you can see that under the solutions. And 0.8 to the fourth power meant 0.8 times 0.8 times 0.8 and so on. And so I'm going to do 8 to the third power. And it wants me to say what is the base and what is the exponent. Well, the base here is always the big number. Base is big, 8. Right? Base is big, negative 1/4. Base is big, 0.2. And the exponent is to the power of. Well, this is to the third power. And the power is really another name for exponent. Actually, power is the whole thing. Exponent is just this. This is 8 to the third power is the power. So the exponent here is 3, the exponent here is 2, and the exponent here, of course, is 4. And the other part of it, it says, is to identify the base and exponent. It actually doesn't even say to solve it, right? We don't have to do that like it did in the example. But this would mean 8 times 8 times 8. This would mean negative 1/4. Times negative 1/4 would be a positive 1/16 because you would times tops times tops and bottoms times bottoms. 8 times 8 times 8 is, don't quote me, but I believe 512. And this means 0.2 times 0.2 times 0.2 times 0.2, which is 2, 4, 8, 16. 16 with 1, 2, 3, 4 decimal places, if you remember how to do that. And that would have been my answer on that one. Okay? All right. So we're moving on to example 2, where it starts talking about the difference between whether it has parentheses or not. And this is a big one that students mess up, right? Negative 5 to the fourth power means negative, and then 5 to the fourth power. And it means negative 1 times 5 to the fourth power. So they went negative 1 times 5, 5, 5, 5, and you get a negative 625. Whereas a negative 5 in parentheses means taking all of negative 5 4 times, like they do there. Okay, and that's what these next few are about. I'm going to go through the skill practice problems here. Hang on a second, I just dropped my notes. Don't want to miss anything here. Alright, so negative 2 to the fourth power, again, means, well, let me go back to this one. When it's in parentheses, it means all of it that many times. So negative 2 times negative 2 times negative 2 times negative 2, which is negative times a negative is positive, times a negative is negative, times a negative is positive, 16. That's the answer for that one. Okay, I don't need you to put the plus sign there, of course, but that's what that means. Now this one here, though, means, because the 4 is attached to the 2. Here the 4 is attached to the whole thing. Here the 4 is only attached to the 2. So this really means negative, and then 2 times 2 times 2 times 2. Right, which is negative 16. Okay, well that's a big difference between that one. Negative 16 and positive 16. Okay, kitty, go on. Go ahead. Right. Sorry, my cat was in the room and she's pawing at the door. I'm sure you could hear her. She's a very vocal cat. Now, if it's to the fourth power, it does matter, or even power in general, second power, sixth power, etc. If it's to an odd power, it doesn't, because this means negative 0.1 times negative 0.1 times negative 0.1, and a negative times a negative is positive times a negative is negative 0.001. Whereas this means negative 0.1 times 0.1 times 0.1, which is still negative 0.001. So really, it doesn't matter when the exponent is odd, but it certainly matters when it's even. Okay, because if it happens 4 times, it becomes even. If it happens 1 time, it's odd. It's negative. Okay. All right. So on the side of page 361, there's a concept connections, and here's what it says: will the value of a negative base with an odd exponent be negative or positive? So a negative base with an odd exponent. A negative base with an odd exponent is going to be negative all the time. Okay, and there's my example right there. Right, number 9 says, will the value of a negative base with a positive exponent, or with an even exponent, excuse me, be negative or positive. And here again we can see this is a base that is negative with an even exponent that became positive. Okay, excuse me, positive. Alright, so let's move on here. So in example 3, it starts to show you here, let's see if I can slide this up here, here we go. Okay, it starts to show you plugging in a equals 2 and plugging in b equals negative 3. So for this I just plug in 2 here, and then let your calculator do the work, because technically you have to do exponent first because of PEMDAS, right? But if you plug in 5 times 2 to the second power, your calculator will do it for you and just tell you it's 20. Right? You don't have to show all this work. Same thing here. If I plug it in here though, 5 times 2 is 10, 2 to the second power is 100, and that's a different deal. But again, if you plug it into your calculator as 5 times 2, put a parentheses around it squared, you can get 100 from that. Okay. The next one, again, if I plug it in, 5 times 2 times negative 3 squared. I have to do PEMDAS, have to do this first. That gives me 9. 5 times 2 is 10, times 9 is 90. Again, you can plug all of this in at one time into your calculator and it'd be good to go. Okay. Right here, same kind of thing. It would be, it says it on the next page, it would be negative 3 plus 2. And because it's in parentheses, I have to solve that first to get negative 1 squared, which is positive 1. Okay, so let's take a look at it on our examples, right? On example, let's see here, we're on example 10 already. Okay, all right. Number 10, we've got 6x squared. Well, it's telling me that x, maybe I should write this, x equals 2, y equals negative 5. So this is 6 times 2 squared. And again, you could plug that right in your calculator, 6 parentheses 2 parentheses squared, and it'll spit it out. But this is 4, and that answer is 24. Okay? Whereas if I plug 2 in inside the parentheses, I got to do what's inside first. 12 squared equals 144. You can see the difference whether it's inside or outside. Everything I plug in, though, I'm plugging in parentheses. So when I get 2xy squared, I'm going to go 2 times, well, 2, and then the y here was negative 5 squared. So now again, remember PEMDAS says I got to do this first. Again, if you plug it all in, your calculator won't make mistakes if you plug it in using parentheses. But negative 5 squared is 25, so 2 times 25, because a negative times a negative is a positive. Okay? Sorry about that. And then 2 times 2 is 4 times 25, right? We would not distribute the 2's into both, right? We would just do that. I get 100. Okay? For 13, y is negative 5, x is 2, and negative 5 minus 2 is negative 7 squared, which is 49. Okay? So make sure that you're plugging it in correctly and then use a calculator, or else you can kind of double check yourself by doing this. Okay? Alright, so from there, what's next here? Alright, so on the next page, and now again, I'm on page 362, okay, I have the properties that they're giving me at the bottom of page 362, which are multiplying like bases and dividing like bases. Alright, so BM, sorry, my wife was calling, I have to make sure that she knows what's going on. BM times BN gives me b to the m plus n power. So when they have the same base, you add the exponents. When they have the same base, you subtract the exponents when it's divided. So b to the m minus n. So here's what they mean. Q4, so they give you examples. Example 4, it's really simple. They try and write it all out, but I don't even need to do this. This would be 4 Q's and 8 Q's, which gives me 12 Q's. Again, because I can just add 4 plus 8. I can just add 4 plus 8 and get 8 to the 12th, right? Do I want you to tell me what 8 to the 12th power is? It's a little bit big. I probably won't give you stuff like that big, okay? For division, though, again, we subtract. So this is just 15 minus 8, which gives you 7, right? For this one, 15 minus 8 is 7, so 3 to the 7th power, okay? All right, so let's take a look. What does 18 say, okay? This right here on top is just like the rules that we already had. We add the exponent, so that's A11 over A7. Right, this is just putting 2 steps together. We're going to do the add step and the minus. Now, could I have done the other one first? Sure. I could have subtracted those and got A1, and then A1 and A3 would give me A4, just like it would give me here. 11 minus 7 gives me A to the 4th, right? Number 19, skill practice 19. So again, this is just continuing to do the same stuff. Skill practice 19, I am on, now page 364 by the way. I'm going to solve what's on bottom here first. So I've got 5 to the 9th over 5 to the 7th because 2 plus 5 equals 7. And now division means subtraction, right? So 9 minus 7, I'd get 5 squared. And that's a small enough number. 5 squared is 25. Okay? All right. So let's look at what it's trying to do in example 7 here. All right. So on example 7 here, okay, it gives you an equation, and all you need to do when it's multiplied is just multiply everything. So 3 times 2 is 6. That's how I get that. P2 and P1, when there's nothing here, it means P1. It's just add them. 2 plus 1 is 3. And Q4 or Q5 gives me Q9. And this is simple as that. Done. Okay? When it's divide, now they're trying to show you on the next page here. Okay? When it's divide, we divide numbers, and then with exponents, remember we subtract. So 16 divided by 4 is 4. 9 minus 8 is 1, which they don't put the 1 there, but you could. And Z3 minus Z1 is Z2, right? So remember, when there's nothing there, you put a 1 there. Now, that doesn't apply to this one. 4 times 3 is 12, right? X2 and X5, when they have the same base, you add the exponents, is X7. And Y3 and Y7, when they have the same base, you add the exponents, is Y10. Simple as that, okay? All right, so now, sorry, I think you couldn't see that, but again, 4 times 3 gave me 12. The 2 plus 5 gives me 7. 3 plus 7 gives me 5. Now with divide, again, one step at a time. 81 divided by 9 is 9. X4, when there's nothing there, it means a 1. So when it's divide, we subtract 4 minus 1 to get 3, and 7 minus 3 to get 4. Okay, that's it for that. Okay. Now, it next gets to the compound interest formula. And they talk about simple interest here, which is given by this equation here, I equals PRT. And we talk about compound interest down here, which is A equals P times 1 plus R to the T power. If you had Algebra 2 this past year, you probably did compound interest with an R over N to the NT power. We're not even going to get that difficult. We are only talking about annual income, right? This is interest annually, not quarterly or monthly or anything like that, okay? And then it goes through and it starts to show at the top of page 366, excuse me, it shows a concepts connection box. And you can kind of see my work here. I'm going to write it down on the paper too. But it's given me, it says just write out the equation. That's all it wants me to do is just write out the equation. And what's what? Well, P is the principal, so that's the 19,000. R is the interest rate of 7%. And T is the time of 10 years. And then I just went and plugged it all in. So here's what I mean. Okay. So on number 23, A equals the amount. P equals, well, this is 19,000. That's my principal interest, the stuff I initially value. R equals the interest rate, which is 7%, which as a decimal is 0.07. You need to always change those percents to decimals. And then T, being my time, is 10 years. So I just plug it in as A equals 19,000 times 1 plus 0.07 to the 10th power. And I just plug it right in like that to a calculator and it gives me the answer. Now I could write this as 1.07 to the 10th power and do it that way, but I don't even need you to do that. Okay. On the next problem, again, as long as you plug in your parentheses as it should be. P is my principal for the skill practice number 23. You can look at example 8. It's identifying them, it's plugging them in, and it's simplifying it. I don't even need you to do all those steps. I'm going to show you this. This is a skill practice problem where my principal is 4,000 times, it's always 1 plus the R, the interest rate, which was 5%, which as a decimal is 0.05. Okay, you got to change the percents to decimals. And then it says after 3 years, so like that. And you can, ladies and gentlemen, you can plug it in just like that and it'll spit it out. Or, again, if you want to simplify this to go 1.05 to the 3rd power, then you just plug that into your calculator. And when you do, you get $4,630.50. So if I asked you how much interest did they earn, you would say $630.50 because it started at 4,000 and it got to here, right? All right, that's it. that's the notes for today. Your homework, there's a lot of problems, but they go really fast if you haven't noticed that already. Okay, is page 367 through 369, number 15 through 23 odd. You know what? I'm not even going to do this. I'm just going to let you copy it down from that. Okay, if you want to pause it and write that down, or else it'll be on Canvas as well. 15 through 23 odd, 33 through 34, 40 through 54 even, 61, 63, 69, 75, 77, 85, 91 through 99 odd, 103, 107, 113, 115. This will go a lot faster than you think. Okay, it really will. Okay, and I will know that for sure because I'm going to do the assignment as well. Okay, that's it for today, y'all. Just trying to remember those exponent rules. See you tomorrow.